Okay, today is June 24th, Friday. Okay, we're going to do two things this morning. Okay, I'm going to review quickly the first half an hour, the material that we covered yesterday. Okay, it was just an introduction to energy methods, and then in the second part, second half an hour, I would like to see if there is any asking any questions about assignment 3. Okay, so I'm going to leave the last part of this session for that. Okay, so let's just a review. This is just a review of the yesterday's session. Hopefully we will have no problem with the connection. Okay, Andy, would you please confirm me that you see my full screen? Andy, full screen?
Yes, doctor, I see.
Okay, so these are the topics that we're going to review in this chapter. Elastic strain energy. Is possible that you see some of these, that you studied some of these in the solid mechanics course. Then we're going to use a very simple principle, conservation of energy, to calculate deflection. And then next session, we're going to cover the last two topics. Okay, so this is kind of a short chapter. These are some of the terms that we're going to need. This is the basic idea. Okay, so in this figure, I prepared manually. In blue, it's an original system. And on this system, we apply a force, F, okay? And because of this deflection,
People, the Dr. Marin had a problem with the internet connection, so we are going to do something. If you have a question about the assignment 3, let me know. If I can answer your question, I will do, or I will ask to Dr. Marin after this class. So if you have a question, please go.
I have a question of the assignment number 3. The question and the second part. We have to design a beam or a grider or something in AutoCAD.
About what problem?
The problem number 2.
The problem 2.
A grider or just a single beam?
You have to do the plan. Okay, Dr. Marin is here.
go on. I still have to make a couple of connections. Go on.
You have to do a 3D plan in AutoCAD, but I don't understand what is your question.
The 3D model is a beam or a grider? I don't know how to explain it. It's just only a single beam because it's the section the doctor said that
you have to do all the section in AutoCAD. This is a transfer view. You have the spacing between the deformants and the length of between the bulkheads.
Okay.
Okay. Is there any other question, people, about homework? Let me present here. Do you see the assignment? Do you? I'm sorry. This is not. This is not, shoot. And QA. You, oh, here it is. Okay, can you see the assignment?
Yes, doctor. Hidro, I answer your question or no?
Yes.
Se bugueó.
Go on, Andy, because my connection is very unstable. Okay, so please try to answer questions. And if there are some other questions that there is still some doubt, please write them down and send them to me. I'll try to answer back as soon as I can. Okay?
Yeah, I said it.
Go on, Andy.
Okay. Another student, do you have a question about the assignment 3? Like, for example,
Yeah, Andy, I had a question.
go on.
Yeah.
About what problem?
Problem 2. Is possible prepare the 3D plane in the Rhino or AutoCAD?
Doctor.
Okay, I think it's better if we stay with one single program. Okay, so what you can do if you feel more comfortable, you can use Rhino and then you can import it to AutoCAD. Is it possible?
Yeah, it is possible, but
Okay, so
I think it's better in Rhino to see.
Okay, I can give you the choice. Okay, you select the choice. You either use AutoCAD or you can use Rhino if you want. But
Thank you, Doctor.
I prefer to use one single program because when well, not me, because the assistants are the person who review that. Okay, they have to open some of in this and some others in other software. It brings, I mean, takes more time. That's the only reason. Any other question, people? Does anybody have started problem one?
Yes, doctor.
Okay. Do you have any questions about problem one?
Yes, about the actual section distortion of the section, the number 3 of 1.
Okay.
So do we have to draw how it go to this place, or just prepare an Excel with the values?
Now I prefer, see, usually what happens is that it's more, I mean, I want you to receive the message, right? That when we have shear, there is some axial distortion of the section, right? So if you see in a table, those are numbers. That's why I prefer that you draw, okay? So what you can do is you can, for example, prepare something like this, right? So this is the section, right? This is X, of course. And you pick, you can pick, for example, this is very important, of course, and you can take one middle point here. This is going to be symmetric, right? So there. So you start at 0, so that's something that we know. So you can calculate here, there. is that you can include points. I don't know what's the solution. And then you can connect them with a curve. Remember, this is vertical, this is horizontal. So draw with two different curves, right? One for this part and the other for this part here. Like that. And give me a scale. For example, this is, maybe this is 0.1 millimeters, right? So you have a general idea of this, of the dimensions of each one of these. Okay, and then downwards, something similar, right? Maybe it's possible that this is negative. So the idea is that if this would follow the kinematic assumption, this would be a straight line, right? So it would be something like this. And here, you will have a single value for the whole deck. That's following kinematic hypothesis. The section is like this, and it does this and rotates, but it's still straight. Now, we are seeing is that because of this is shear. It does this, but also it makes something like this. Well, this is extreme. So it's not straight anymore. Okay, and because of this, in the closed section, does something similar, okay, in between, okay, this elongation generates a change in the normal stress distribution. That's what we are calculating. So that's why I prefer Ms. Santos. I prefer that you try to summarize this in a 3D diagram.
Doctor.
Just a second. Let me see if I answered Ms. Santos' issue. Ms. Santos?
Yeah, so do we have to do the 3D diagram for each point? So the shear, stress distribution, and normal stress?
No.
Or just for the distortion?
It would be very nice if you prepare the 3D for the 3 points, yes. But I prefer at least for the last one, because one thing is normal stress, right? Normal stress is something which is, yeah, it has some physical meaning. But this case is a displacement in that direction. This is U, okay? Remember, U is the displacement in X direction. So if you plot and say that this is the X axis, this is the displacement in that direction. And displacement means, that's what I said, include an scale. So you start having a physical interpretation of that. Okay, so this one, yes, I definitely I prefer to employ the 3D. In the other cases, if you have the time, do it. Because you will see it in a graphical way, which is, I think is preferable. Santos?
Okay, doctor, thank you.
Okay, there was a question from somebody else.
Yeah, it was me.
Okay.
It was about this part too, but I made this graphic so in 2D, but I have this quadratic behavior of the part, but in the webs. But on top, for example, yeah, you should have a curve, yeah, like a quadratic distribution too. It's not going to be linear, yeah.
No, it's not going to be linear.
Okay, and it should be the maximums in the joint.
One thing, people, you have the integration, so you have the variation, so you know how the variation it is on the webs and also on the decks. So you can evaluate it in 2 or 3 points, and then you can draw a curve, a decent curve for each one of these parts. Yeah. So as we said, okay, it's not, I'm not asking you to do any integration. So your responsibility is you have to review the process. It's in the class notes. And from there, once you review, you pick the expressions that you need to apply. So that's, I mean, you are responsible for doing that. And when you review and you select the expressions that you need, I mean, you are practicing the details of the process. And that's what I want. Okay.
Thank you. Yeah.
You are, please be careful. This is something that we have said many times. I'm going to say it again one more time. Be careful with the units. Be careful with the units, okay? For example, if I ask you, Mr. Carranza, would you show me with your fingers, okay, 0.1 millimeter? Show me with your fingers, 0.1 millimeter. Can you show me? Can you show me 0.1 millimeter with your fingers?
Yes, it's smaller.
It's very small. Miss Valdez, can you show me with your fingers? How much is 0.1 millimeter?
Ref?
Yeah,
Very
okay. That's small amount, right? So it's a good thing to have you in your mind, okay? The concept that these are very small quantities, but still with an adequate scale, we can see the variation of those values. Okay. Okay. Is there any other questions about this?
Yeah, I have a.
You have another question, Ms. Santos?
Yeah.
Go on.
About the normal stress distribution, we have to consider the shear stress for normal stress and the Taylor for normal stress.
Yes, yes, you have to.
Okay.
You have to. You have please. You have expressions for all of these terms. In the class notes, you have expressions for all of these terms. For all of these terms. So, as I said before, what your job is review the process, see what I'm asking you, and then get the correct expression to respond to the question. I'm not going to say apply equation 2 point something. No, you have to do it. You have to solve it. You don't even have to solve it. You have to review the process and get the correct expression to respond to the question. Okay. So an Excel table is quite useful. Or, for example, I like programming. You could do also some programming. So you can get all of these results, okay, in a TXT file. And from there, you can import it into Excel, and then you can proceed to plot. So there are many ways that you can do. Okay, so if you like programming, you can do a very simple program. So you evaluate, okay, each one of these terms. You can include the expressions, and you simply evaluate many times, okay, in many positions, Y, S, and then have all of these results in a TXT file. And then you can import it from Excel and proceed to evaluate, to plot. You can even plot in Python. There you have it. Mr. Medina, Williams, Medina, good morning.
Yes, good morning.
Do you have any questions about the homework? Have you started the homework?
Yes, doctor. No any questions.
You started the homework, the assignment number 3?
No, doctor.
When are you planning to start? I like you to be honest. I like you to be honest. Okay, when are you planning to start, Mr. Medina? Don't tell me tonight. Today is Friday, okay? And Mr. Waman, are you going to work tonight, Mr. Waman? Are you going to work tonight, Mr. Waman?
Yes, doctor. Because
come on.
Yes,
It's
I want
Friday.
to get the weekend.
Mr. Williams, when are you planning to start the assignment number 3?
Start the afternoon.
Okay, good. Good for you. Good for you.
Night.
Mr. Gomez, Christopher Gomez, have you started the assignment number 3?
No, doctor.
Now, when are you planning to start?
Excuse me?
When are you planning to start the assignment?
Saturday, Monday, and Sunday.
Yeah, well, be careful because when is this due? When you have to complete it? Do you remember when do you have to complete this assignment? Ms. Valdez, when do you have to complete it?
Tuesday next week.
So yeah. Ms. Avilés, have you started the assignment?
Hi, doctor. Yes.
What have you done so far?
So, sorry?
What have you done so far? Have you do any calculations?
Yes. I did the first exercise.
Okay, so
Already, yes.
okay, good.
I don't
good.
have problem in that exercise, but
Good.
today I
Okay.
will need to start the second exercise.
Good. How many hours did you spend for the problem 1? How many hours did you spend for that? More or less, how many hours?
Hours.
For problem 1, for problem 1, 4 hours. That's a good
Yes.
time. That's a good time. Okay,
I
good.
did the exercise in that time, 4 hours. Yes.
Good. Let me ask somebody, Mr. Llanos, Andy Llanos.
Good morning, doctor.
Where are you right now?
I am in Caluma, in my home.
Good. How is the weather in Caluma?
It's cold, doctor. Yeah.
Oh, man. Have you started the assignment number 3, Mr. Llanos?
I started the last Wednesday.
Okay. The
Yes.
last problem? Okay.
Yes, the first problem I finished.
How many hours did you spend for that, Mr. Llanos?
Between 4 and 5 hours.
Okay,
Yes,
4 or
yes,
5
doctor.
hours. That's a good time. That's a good time. Okay.
Yes,
Okay. I would like to let me share a piece of the where are you? Where are you? Let me share. Okay. That's not here. Let me.
Doctor.
Yep.
I have another question. It's about the last part of the assignment. You put something about to make a video.
Yeah.
It's what about that? The assistants are gonna give us what we want to explain, or how you're gonna make it?
If you prefer to explain some part of the assignment, do it. Okay. So Andy is really busy trying to do something else. So you pick any part of the assignment and you just prepare a video explaining that. See, all what we need from that is that you practice your English. That's all. That's all. And when you explain something, that's something that happens to me. Okay. When I have to give a new class, for example, right? I have to prepare the material to explain. And then the person who gains more, it's me. Okay, so if you have to explain something to prepare this video, you will be the person who earns the most, who gains the most. Okay, so that's the idea. So you can select a piece of the assignment. If you think you can explain in 3 minutes one of the problems, that's fine. It's kind of difficult, right? Because it's kind of long, I know. So you can pick one piece, one part of the assignment. Or for example, what you can do is you can, for example, project the distribution of normal stress, right? And you can explain, for example, the differences of this distribution with the distribution that you would obtain if you would not include any influence from the shear, right? So that there are little pieces, okay, that you can select. I suggest that you try to summarize in 3 minutes how you solve problem 1 or problem 2. Okay, that's what I suggest. Okay, can you see the rules, the DNP rules now, Andy? Can you see my DNP rules? Okay, so these are the rules that you will have to use, okay? People, these are a little bit different from the rules that sometimes you have to use. And the difference is this, okay? This is especially for ships with lengths less than 100 meters, okay? These are not the general rules. They are more specific for smaller ships, okay? So in this case, this is the one that you need to use. Okay, now here, you see the content, okay? Okay, there are several sections, okay? And then for the deck, see, this is section 4. You can read longitudinal strength, okay? Section 6, sides, and I missed section 5, bottom. Section 5 is bottom. Section 6 is side, and section 7 is deck structure, right? So here is the deck, and you can find details to design the deck, okay? And one of the things that you find here is the design loads, right? So let's go to, this is the design loads, okay? And this is the table that you need to use, okay? So you see that this is specifically for decks, okay? So for example, weather decks, that means that these are decks which are open, okay? There's nothing above that. See, there's weather decks. And this is the formula that you need to apply, okay? And you see here the units resulting from these formulas. So you see that if you apply this formula, A multiplied by times P sub dP minus this combination will give you P1. And that's the pressure in kilonewtons per square meter that you need to apply to a weather deck. Okay, so that's what you need to do. Okay, so go into this document, take a quick look so you get familiarized with this, this information. And then what you have to do is identify what's the meaning of each one of the variables, right? So in this case, we have the letter A, and here we can see the explanation, okay? Mr. Nieto, would you please read A? Mr. Nieto, could you please read this part here?
Okay. 1.0 for weather decks forward of 0.15 L from FP. For forward of deck house front, whichever is the foremost position.
Okay. Let's find somebody else. Mr. Kimi, Elvis Kimi, please read the next line. Mr. Kimi, Elvis Kimi, please read the next line. Oh man, that means that this person is not here. Andy, please. Mr.
Yes,
Dominguez, please.
Doctor, is me Andres or Elvis? Elvis.
Elvis. Mr. Dominguez, would you please read next line?
Yes, doctor. Vertical distance in meters.
No. A equal
1 for weather decks.
No. We read that again already. We need this part.
0.8 for weather decks elsewhere.
Yeah. So this is typical of these regulations, okay? They give you apply this value for this area and this value for that area. Question for everybody. What is the value that you are going to use? 1 or 0.8? Please raise your hands if you want to participate. Are you going to use 1 or 0.8? Raise your hand or I'll call somebody. Let's read it again, okay? Let's read it again. Let's see somebody. Miss Acuña, are you there, Miss Acuña?
Yes, doctor.
Would you please read again this part here?
1.0 for weather digits forward of 0.15 L for SP or forward
from
sorry. From,
okay, just a second. What do you mean by FP, Miss Acuña? What do you think FP means? What do you think? Anybody? What do you think?
I don't know if it's in the forma hidrotáctica.
Forward perpendicular, right. So you see this ship. Here you have the forward perpendicular. Go on, Ms. Acuña, read the rest. So this parameter A,
forward of the deck house
from
which were
equal to
0.8 for weather digits elsewhere.
Okay, so question for everybody again. What value are you going to use for A to calculate the pressure? Come on.
Is 0.8.
Why, Mr. Pesantes? I agree with you, but why?
Because is the plan of the ship. In the first line is the forward of the house in the front.
Exactly.
Or
forward of a point 15 from forward perpendicular. So we are a little bit behind. That's why we need to apply 0.8. Okay. Yes. Okay. You see? That's easy, right? So let's go on. The next term is P sub dP. Okay, so P of dP is as given in section 5, B101. So what we have to do is let's go to section 5, B101. So this is section A. I'm sorry, I have to go here. What is B101?
But this is section 7. We want to go.
This section 7.
Upward.
Is it? Oh, yeah. Let's go to section 5. I get confused.
But in section 5.
So there's here we are in section 5. Section 5, right? B, what was it? B what?
101.
101. Okay, here we are. There you go. So here you have the formula. Okay, don't worry. In the evaluation, I'm not going to ask you apply. I can ask you apply the formulation. And if you practice for the homework, you have skills enough so that you know what this means or that. Okay, so after this, you go back. Let's do something. Okay, let's suppose that you obtain a value of pressure, kilonewtons per meter squared. Okay? Is there any way that you can check that your results are adequate or not? Is there any way that you could think that you could check your results? People?
Maybe checking with the yield point of the material.
No. The thing is this, right? Let's suppose that in a couple of years, you have an assistant, okay? It's going to be a student in ship structure. You are already have become an engineer. So you have an assistant and you ask him, please, assistant, calculate the pressure on the deck. He opens this document, calculates and give you a number, any value, kilonewtons per meter square. You take it just like that, or you do any check. Of course, you have to do some check. Even though he's a good graduate or he's a good student, it's from the best university in Ecuador, but still you need to check. How can we check if this value makes some sense or not? Any ideas? This is something that we should always do. But you have it, if you have a physical meaning, we can imagine ways to check results. Ideas?
Yes, doctor.
Yep.
In this part, I asked the velocity.
No. This is a quasi-static pressure. Quasi-static pressure. See, they have calculated, they have seen some experience, and they have transformed into a formulation. So here you have a quasi-static value. This is what I would do, okay? Let me draw. Not necessarily is the best, it's just one way to do it, that's all, okay? Let's suppose we have, this is the ship, okay? And here, this is the elements that you need to check, right? So let me change color. Let's suppose that we have water on the deck. Let's suppose that this is a mass water on the deck. If I give you this mass of water, can you calculate the pressure in here? How can you calculate the pressure?
The weight of the mass divided by the area.
Or
the weight of that mass divided by the area in the bottom.
That's too much. Is there any other way? Specific weight of the water multiplied by, Mr. Woman, multiplied by
volume.
Now, this is pressure. Multiplied by, come on, people.
Yes.
Yes, by H. Okay, so you have this pressure because you apply the formulation and you want to check if this makes some sense or not. How much is this? Anybody remembers how much is this? The specific weight of the water?
1.025 tons per meters cube.
We can take this to kilonewtons per meter cube. So this is in kilonewtons per meter square. So from here, we can calculate h in meters. Now, is there any value that you can imagine for this height? Remember, this height of water generates a pressure which is equivalent to the value that you calculated using Dnp formulation. Now, people, we have to start thinking about physics, okay? How much height do you think it would represent this pressure calculated using Dnp formulation? Any value for the height that you can take? It's just to be a few millimeters, centimeters?
No.
It would be 10 or 20 meters? Give me a value.
15 meters.
How much?
15.
15. Man, that's a lot.
4.
Or I don't know. But the thing is this. Think about this is the ship. Here you have the pressure. How much is the pressure here? If this is the draft. How much is the pressure? Come on, people. Don't tell me you're copying on physics.
The buoyancy, density per gravity.
No, please, please. Pressure has units of force per length squared. Buoyancy has units of force. How do you calculate the pressure on the bottom? It's equal to gamma T. Okay, so gamma is again the specific weight of the fluid, seawater, and T is the draft. Okay, so if you say that this is 15, okay, that means that you are thinking that above this, you have a column of about 15 meters. Can you imagine an amount of water here, which is 15 meter high, acting on the deck?
It's a lot.
It's just too much, I think. Okay, so I'm not going to give you my number. So the thing is that after you calculate the pressure, calculate the height and see if that makes sense or not. Okay, but I think 15 meters is a little bit too much. Okay, if you obtain a value of what? 10 centimeters. I mean, you can physically see, you can have something 10 centimeter high and see the, try to feel the pressure in below. The pressure is nothing. You swim, right, into a swimming pool, and you see that if you go, for example, 3 meters deep, and you start feeling some pain on your ears, right? That tells you a little bit of the amount of pressure that you are feeling in 3 meters. So let's start thinking about that. I mean, okay, let's start always trying to do these kind of things, okay? Always, every time you calculate, there must be some way that you have to check your results. And this is physical. Okay, people, I'm sorry about the problems that we have at the beginning of the session. I don't know, something happened, and then everything settled down, and yeah, we can finish our session. If you have problems with the assignment, problems 1 or 2, send us an email, and we will try to answer as soon as I can. Okay. Don't send them to those questions at Saturday at 10 p.m. Okay, so if you send us, either send today or tomorrow morning, okay, because we have personal lives also, right? Right, Andy? You have personal life, right?
Yeah, doctor.
Yeah, so, yeah, but if we receive questions, for example, this afternoon or tomorrow morning, we will try to answer back as soon as we can, okay? But please, I asked some of you, and not many of you have started the assignment. And I just can remind it to you. That's all what I can do. It's your responsibility. Remember, in this class, every assignment is obligatory. You don't have the choice. You want to pass this class, you have to do all the assignments. Okay? Okay, people, let's pray for our country that finally we will find a point where these people can sit and discuss, and we can find a solution for that satisfy both sides. In the meantime, we have to keep doing our best, and our best is to study. Okay? Have a nice weekend. See you Tuesday. Bye-bye now.